Hello, we're Team IGT and our project is called the ShowController Refresh. Our technical directors for this project are Raymond Leland and Eric Hanley. They are both URI alumni. This is our team. I'm Kartik Mohanty, an electrical engineer. I worked with Andy Yu, an electrical engineer, and Nathan Campano, a computer engineer. Before we get into our project, here is a little background on the company we are doing the project for. IGT is headquartered in London, England. They have operating offices in Rome, Italy, Las Vegas, Nevada, and here in Providence, Rhode Island. They are the world's leading end-to-end gaming company. They produce lottery machines, slot machines, and other types of gaming technology. So if you have ever walked into a casino or retail store, you might have seen their machines. Now here's the motivation behind our project. IGT has a dual display media player called the ShowController. It is mainly used for retail digital signage and serves as the main source of lottery advertisements for retail stores. The goal of this project is to update the existing version of the ShowController with a new and improved version. The anticipated best outcome of this project was dependent on the initial buy versus build analysis, which we'll get into more depth on later. But if the buy option was chosen, then the ABO was to buy a commercial off-the-shelf device, integrated with IGT's platform and digital media software, and have it ready for the market by April 2023. On the other hand, if the build option was chosen, then the ABO was to develop a prototype device, do the software integration, performance test it, and then transition it to IGT by April 2023. The good news is that our ABO was achieved. What ended up being requested and delivered to IGT was a slideshow presentation containing the results of our buy versus build analysis. It also included our performance and benchmarking results, which we will discuss more in detail later. And then at the end, we gave our recommendation to move forward with the build option and our recommended parts to use in developing the prototype device. This slide contains all of our major team accomplishments. Our accomplishments include the buy versus build valuation, the component research, benchmarking tests, and finally the documentation and presentation to IGT's engineering team. Digital signage is essential to lottery systems as they provide the players with key lottery information. The new ShowController will be one of IGT's products for retail companies who wish to use digital signage on multiple monitors simultaneously. Now I will talk about my specific individual accomplishments on this project. I, along with others, performed the buy versus build analysis of the project and recorded our findings into a spreadsheet. I also did research on potential central processing unit or CPU options for the ShowController. In addition to that, I helped my team run and record results for the performance and benchmarking tests, which I will let them discuss after me. And then finally, I made the presentation slides for IGT's engineering team. The purpose of the buy versus build analysis was to determine if there is already a video controller on the market that satisfies the requirements of the new ShowController. This is a screenshot of the spreadsheet we recorded our findings in. The spreadsheet is obviously much larger than it looks in this picture, but we wanted to give you an idea of how we recorded our information. As you can see, we did find multiple video controller options online, but none of them really satisfied every requirement of the ShowController, so we decided that the build option was best moving forward. And then we started researching the individual components for it, which you can see some of them at the bottom of the screenshot. So there are multiple components to research, but the component I specifically researched was the CPU. So the CPU is essentially the brain of the computer. It is located in the motherboard and it is in charge of processing all the computer's main tasks. There are many companies that make CPUs, but we focused on those that were made by Intel. I researched multiple options and recorded 4 CPUs that we decided to narrow it down to. In this screenshot here, you can see a side-by-side comparison of each CPU and its important specifications. The column on the left in red is the CPU that is being used for the existing ShowController right now, while the other 4 columns are the new CPU options that are being compared to the existing one as well as each other. Here's a simple block diagram of how the ShowController works. This laptop here in the bottom left corner is called a ShowMaker. This is where you make the graphics that will be displayed on the monitors. It is then sent up to the terminal management system, which then goes through the internet or network, and then an Ethernet cable is used to send that data to the ShowController, where the graphics can be displayed on 2 monitors at the same time. So I will now pass it off to Nathan. He will talk about his individual accomplishments on this project.
Thank you, Kartik. So as a computer engineer of the group, I was assigned with the responsibilities of working with the pre-existing ShowController itself and helping troubleshoot with any other software problems that may arise during the completion of the project. When starting this project, I quickly realized that the existing ShowController is operated through the Linux command line terminal via SSH. Because of this, the first thing I had to do was research the relevant commands and to get familiar with how terminal operation works in general. I was also tasked with learning how the file system of the device is structured, as well as learning how to demonstrate the output capabilities of this device with the diagnostic shows. After getting familiar with these things, I also needed to do some HTML5 benchmarking of the VCU and comparing it to other prototype boards. Lastly, I had to help integrate the new version of IDT's custom Linux distribution onto the board, which we felt was the best fit for this updated device. So here is an example of the ShowController outputting a display to 2 different monitors with IDT's custom diagnostic test shows. We mainly use these shows to see the difference in performance between the devices by measuring the frame rate and overall picture quality of each test. And we also did a little bit of configuration, adding more stress to the CPU, where we had, like on the right monitor, you can see there are some balls bouncing. We would add more balls and see how many would be required to make the performance lessen. So, like I previously stated, I focused on the HTML5 benchmarks of the devices. We chose HTML5 as a specific benchmark type for these devices because it most closely relates to the types of processes that the device would be running in a real-world scenario, whether it's in a store or anywhere else you might see a lottery game like Keno. Here on the spreadsheet, we can see multiple different boards configurations and their measured performance for each test. The tests with the biggest improvements are Speedometer 2.1, which focuses on the responsiveness of web applications, MotionMark 1.0, which focuses on testing the browser's graphic capabilities, and WebBaseMark, which is just an overall HTML5 capability test. Based on the comparison of these 3 main tests, it's clear that the best choice of CPU for our purposes would be the X6425E with the 2x2 gigabyte RAM configuration running at 2400 megahertz because of the best performance. I will now pass this off to Andy Yu, who was in charge of the hardware testing and benchmarking for this project.
Thanks, Nathan. My teammates in the early stages of the project, I was working alongside them to research components and viable devices that fit the requirement for the ShowController refresh, and specifically looking into the specification, price, and availability of these components, and as these would be the major factors of if we would be moving forward with these products. I also looked into some online benchmarking and data sheets to determine some of the hardware component performances and comparing them to the existing ShowController's hardware. This would be like the I/O support or the GPU, CPU performances. Then I mainly focused on both the Intel X6413E and X6425E prototype boards and used a common distribution in Linux called Ubuntu alongside a IGT custom Linux distribution to operate it. Through the use of SSH and terminal commands, I was able to benchmark these boards and evaluate the performance of these boards. Installing the benchmarks was essential to evaluate the performance of the prototype boards alongside monitoring the hardware uses and temperatures. These are some of the benchmarking tools I used: ATOP, Hardware Info, Phoronix Test Suite, Sysbench, Chrome Experiments, WebGL, StressNG, GeoMark, and various IGT test shows. These benchmarking tests were done with various hardware configurations and software configuration, which I will talk about the differences of these in the upcoming slides. With these results, I was also able to help the process of creating a formal documentation for the ShowController S2, the buy build document, and the benchmarking results spreadsheet. These are some of the benchmarking results. Using the tools I stated before, we were able to change the hardware configuration on the X6425E prototype board, which used two different RAM configurations, one with the 4 GB and a 2x2 setup. We concluded that the 2x2 configuration performed much better in most cases, even with the slower RAM speed. We also used the IGT custom distribution in Linux to test use for their test shows on the prototype boards. These were the Phoronix test suite results for both the X64E and the X6413E boards. And these are the Geekbench results. Here we can see that the X6425E configuration resulted in better performance in almost all cases, with very marginal price increase. These results can be used to help determine what we were going to recommend to the IGT's team moving forward for the project. In summary, this is what we accomplished as a team: buy and build evaluation formal documentation, links, software and firmware research, key component research, the CPU, GPU, etc., documentation, benchmarking of the existing ShowController and new prototype boards, IGT software and firmware integration tests, and the IGT next generation ShowController presentation documentation, and moving all our research and results to the IGT team. We'd like to thank our Capstone director, Capstone TDs and at IGT, as well as TDs at URI, and our Capstone director, Dr. Sunak. Thank you.